Good day, learners. Welcome to our mathematics lesson for today. My name is Nagile Ndlovu. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. It's a grade 11 session where we are going to be focusing on measurement as a topic, under which we are going to focus on volume and surface areas of right prisms, cones, cylinders. I will also add some spheres. By the end of this lesson, you should be able to identify types of prisms. You should also be able to calculate volume and surface areas of given prisms, cones, cylinders, and spheres. 3, you should be able to choose the correct formula to calculate volume and surface areas of given shapes. You should also be able to study the effect on volume and surface areas of multiplying any dimension of the shape by a constant. We shall see what we mean by that when we talk of multiplying a dimension of a given shape by a particular constant. Now, I have defined a few terms for you there. What do you understand by volume? Yes, you need not to divorce it from other topics that you are doing in other learning areas like sciences, but in particular here we are talking of volume with relation to shapes, not volume in general. So volume is the space occupied by a three-dimensional object or shape. There are so many objects in this world. Each object requires a particular space to occupy in this world of ours. So the space that it occupies is referred to as its volume. So volume is the space literally occupied by a three-dimensional object. Even us as human beings, we've got our own volume. The space that we occupy on Earth is actually our volume. Then a net of a 3D shape is a two-dimensional representation of the shapes, or rather the shape surfaces unfolded and laid flat. In other words, if you have a particular prism or 3D shape, you cut it open and lay it flat on the ground. The space that it covers is its surface area. So remember, these shapes, most of them that are prisms, they are made from 2D shapes or two-dimensional shapes. So when we cut them open, we'll have to add up all the faces together in terms of their area. Therefore, total surface area of a 3D shape is the sum of the areas of all the individual faces that make up that particular shape, which is what we normally call the net of your 3D shape. You shall see later on what we mean by the net of a 3D shape. Right, we have got some different types of prisms. The ones that we are going to study today will relate to what we call regular prisms or right prisms. Not all prisms are regular or right prisms. Some are just but prisms, some are just but 3D shapes. They don't have definite dimensions. Like a stone. A stone is a 3D shape, but it doesn't have definite dimensions. You can't tell which one is the length, which one is the breadth, especially if it's irregular, unlike a brick, building brick, first brick, name them. When you look at them, they are rectangular in manner. That's a typical example of a prism. Right, they've got a uniform cross-sectional area. Right. So we're going to look at some of the examples of prisms that are examinable. The first one is a rectangular prism which has 3 pairs of equal faces. When you look at it right now, we can see there is a length, breadth, and height. This is our length, this is our breadth, and this is our height of the prism, which can also be written that other side, the height. If you continue labeling all sides, you will find that this is still L, and this is our B for breadth, and then this is our height H in that broken line. So as you can see, there are so many faces that are involved here. In the actual fact, there are 6 of them that are involved in this particular rectangular prism. So the front part and the back part are equal in area because they use the length and the height, L and H for the front part, L and H for the back part. That's why we're saying there are 3 pairs. Since there are 6 faces, the top and the bottom, they will go together. The extreme ends, they will also go together. Otherwise, the front and the back, they will also pair up. They are equal in area because the dimensions are the same. Right, that's our cuboid. Some books will call it a cuboid, and the other name for it is a rectangular prism. As you can see, we spoke about a uniform cross-sectional area or a uniform base area. If you look at the base of this particular shape is LB. So if we were to slice this across going up, we would get the same size of our rectangles, which is L times breadth, length times breadth throughout. Whichever way you slice this block, you are going to get equal slices across or equal rectangles across. That's what we mean by a cross-sectional area. If you are to hold it in a particular position and you are able to cut unit rectangles across the shape, then that will give us the same size of rectangles across. Hence, we talk about the area of the base. It must be uniform throughout. That will then speak to a regular prism. Okay. Then here is another one, is a cube, which is made up of squares, whereas the first one is made up of rectangles. So in other words, it's a square-based prism. If you want to use the word prism and you don't want to refer to the word cube, you can call it a square-based prism. In other words, the base is a square. Right, so there are 6 regular faces here. When I say regular faces, I'm referring to equal faces. Each face will have side, side, side. All of them are side, side, side. If that side is 7, all of them will be 7, 7, 7 right round because it's made up of a square. Okay. And then we also have this circular one. This one is a circular-based prism. In other words, the base is a circle. As you can see, the top is a ring. It means the bottom is also a ring. This one is usually referred to as a cylinder. So it's a cylindrical shape. It has 2 circles and a rectangle. In other words, if you were to rip this shape open, you will see 2 rings and cut the curving part out, which is your curved surface area. It will form a rectangle. So generally, a cylinder is made up of 2 rings. You can have 2 rings, have a rectangle, fold it into a curving surface, then you attach your bottom and tops, which are circular or which are circles. Those shall form our 3D shape, which is now called a circular-based prism or a cylinder. Okay, and then we also have another type, which is made up of 2 triangles. Doesn't matter what kind of a triangle you use, as long as those triangles are of the same size, it will become a prism or regular shape in terms of the cross-sectional area, right? That purple shaded region is a type of a triangle. It could be an equilateral triangle, it could be a right angle triangle, it could be a scalene triangle. But at the end of the day, if you were to form a shape using those 2 triangles and 3 rectangles, a triangular prism is going to be formed. That's what we mean by a triangular prism. It's made up of 2 triangles on extreme ends and then 3 rectangles. The rectangles may not necessarily be of the same size. It now depends on the dimensions of your triangles. It now depends on the type of your triangles. But at the end of the day, it's going to be a triangular prism, meaning if you were to slice it across for the whole length of the prism, cutting in units, you are going to form triangles of the same size. Hence, earlier on, we spoke of the cross-sectional area. Okay. And then we are saying the volume of any prism is therefore given by the formula. you don't have to necessarily cram the formula for each prism. These prisms are easily dealt with by focusing. The moment you identify is a prism, you don't have to cram the formula. What you need to do is to look at the base of your prism. If the base of my prism is a circle, what does that imply? It means it's taking me back to a 2D shape, and I know the area of a circle is pi r squared. I'll look at the base. My base is a circle, and therefore the area of a circle will be pi r squared. Then I'm saying these are circles that are piling up to a certain height h. I'm basically piling 5 rand coins up to a certain height. They will form, since their radii are equal, all of them, they will form a circular 3D shape, which is what we're going to call a cylinder or a circular based prism. Now, if you are to find the volume, which is the total space occupied by this cylinder, you are piling up circles of the same size, which is pi r squared. Remember, the area of a circle is defined by pi r squared, where r is the radius. Then if you pile them up to a certain height, then that will give you your volume. So in short, if I were to find the volume of this cylinder, I'll say it's made up of circles, which is pi r squared. That's a circle multiplied by the height. Up to what height am I piling them? So you don't have to necessarily cram this formula. You need to look at the base of the shape. Same applies to the triangular prism. You focus on your base. If the base is a triangle, how do we get the area of a triangle? It's a half base times height. That's the area of a triangle. If I can put a height there, I have found my height. That is a perpendicular height. I will find the area of my triangle. I will say, therefore, volume is going to be half area of base, or half base times height, which is a triangle, half base times height. Then multiply this by the length of your prism. That will give you the volume of your shape. Hence, the area of any prism, as long as it is a uniform or regular prism, we need to be specific here. That is a regular prism. Of a regular prism is given by the area of the base. You focus on the base of that shape, then get its area, then multiply by the height of the prism or the length of the prism, depending on how that shape is positioned. Okay, right. Here is our first example. The diagram alongside represents a rectangular water tank with a length of 7 meters, a breadth or width of 3 meters, and a height of 6 meters. You can see it's a rectangular design. That's exactly what we mean by a cuboid or a rectangular prism. It's made up of rectangles. So obviously they will ask us here to find the volume of our 3D shape, because it can only have volume, total surface area, as well as capacity to a certain extent. Right. So the first part of the question then says, determine or calculate the volume of the tank. Those are the words that we may use when we now ask questions. Determine the volume of the tank. Yes, it might sound easy because we have covered these things in lower grades. That's basically what measurement is all about, right from lower grades up to where we are now. So we just start consolidating the concepts, because the very same concepts that I'm discussing now shall have an impact or a bearing when you come to what we call calculus in the near future as you go to grade 12. You will require these formulae. They are very, very important. They play a vital role in another topic. So as you exit this particular grade, you need to be clear as to how you find the areas and volumes of these given prisms, so that you don't struggle with the next topic, which is going to be calculus. Okay, then 1.2, you need to determine the total surface area of the tank. This now speaks to the faces now, where you are going to break down that particular shape and place the given faces flat and then determine how much space it covers on a flat surface. Then, if a new tank is formed by doubling the breadth of the old tank, in other words, they are changing the size of the tank for some reasons, they've decided to change the size of the tank by doubling the breadth of an old tank. So what this basically means is that you are changing the dimensions by using a particular constant. That doubling effect is a 2. You are multiplying the breadth of your tank by 2. Instead of it being 3 meters, you now want to expand it and make it 6 meters because you are doubling only the breadth. You are focusing on only one dimension at a time. You want to see how would it affect your volume. Obviously, more space is going to be covered if you are increasing the size of your object. But then we want to see what is this effect of doubling our dimension. It could be all 3 doubled, it could be 2, it could be 1, but in this case, we are doubling only 1. We want to see the effect of that particular 2 after changing the size of our shape. Okay, right, so I'm going to give you some minutes to go through the question. Then we'll discuss, since it's an example, it's not an activity. We'll do it together, but I'll give you some few minutes on your own. Go through some of the questions. I'm just going to give you a minute. Then from there, we quickly discuss. Do question 1.1, 1.2, and then double to 1.3, and we shall discuss from there. Yes, let's work. You will also need your calculator with you there for some calculations. Don't take things for granted. Yes, thank you. Let's proceed. So for volume, we are going to use the formula V equals to length, breadth, and height, meaning it's length multiplied by breadth multiplied by the height. So we are going to say our volume is equals to the length multiplied by the breadth multiplied by the height of our prism. So in this case, our length is going to be 7, our breadth is 3, and our height is 6. So it's going to be 7 meters, if you decide to put units, multiplied by 3 meters, which is your breadth. That's how wide that prism is, multiplied by 6 meters. And you can already see there are 3 dimensions involved there: 7 meters multiplied by 3 meters multiplied by 6 meters. Some people don't put units, but if you are dealing with volume, you must indicate as such that the units are cubic units. It indicates that it's a 3D shape and you are dealing with 3 dimensions. When you multiply these 3, this is calculator work, I'm getting 126 cubic meters. That's 126 cubic meters. That's our volume. Okay, then we move on to the total surface area. Right, remember, for the total surface area, we are saying there are some pairs there. There is the length and the breadth. There is the length and the height. There is the length, breadth, and the height. You will realize that L must appear twice. This should be an L. It must appear twice. B must also appear twice. And H must appear twice. Because if you look at the nature of your sketch here, this is your length, this is your breadth, then this is at the top your length again, and then your breadth on the side. Then going up, this is your height. At the bottom, we're going to have another rectangle coming there, which is an L by B. This is an L, that is a B. So they will start pairing up in that manner. On the sides, we have got B and H. Each one will appear twice. So we have 3 pairs here. BH is one set, LB another set, and LH is another set. So according to our formula, we are going to substitute and say our total surface area, this is read as total surface area, is going to be twice. Since there is a common 2, you can see there is a common 2 here. You can factor out your 2. Then you have twice length times breadth plus LH plus BH. Right, so I'm going to say twice, then times length times breadth added to length times h added to b times h, like this. Then from there you substitute twice, you multiply what is your length is 7 meters multiplied by what is your breadth, we say it is a 3 meters, then added to what is our length again is 7 meters multiplied by the height, that's h now, is going to be 6 meters, added to the last one, which is going to be 6 meters, which is your height, multiplied by the breadth, 3 meters. There are our 3 pairs, but we are doubling each area. Each rectangle will appear twice. 7 multiplied by 3 will appear twice, once at the front or at the bottom and another at the top. Front and back, sides, the extreme ends, they will always be of the same size. Hence, we're taking advantage to say, let's find one and then double the result. Eventually, there are going to be 3 doubles there. So we are going to factor out our 2 still. Then we simplify. We're getting 21 square meters. This is 21 square meters added to 42 square meters. This is area now plus 18 square meters. Then you simplify. I'm getting 162 square meters. This is the answer that you should have obtained. Well done if you got that answer. That's how you could have answered that question for the total surface area as well as volume. And when you compare the two here, this is 126 cubic meters versus 162 square meters. Don't think that volume is smaller than area, because they are comparing two different things. Volume and surface area are not the same. You can't say 300 rands is the same as 300 cents, because the units are not the same until you convert it to one. But here we're talking of two totally different things. This is area when the shape has been cut open and laid flat on a surface. That is how much space it will cover in square meters, because the dimensions are in meters. But volume is the total space occupied by this object, intact as it may be. That is, its volume is going to be 126 cubic meters. That cubic meters speaks to dimensions, to say it's a 3-dimensional shape. Then this area here of 162 square meters is now a 2-dimensional representation of the same diagram by changing it to its net. We have cut it open. Then what we are seeing are the faces that build up our particular 3D shape. Okay. Then we're going to proceed and have a look at the effect of doubling the breadth. Our breadth is 3 meters. When we double it, it will become 6. So we're going to find the new volume after having doubled. What will happen? This is exactly what we're interested in now. Allow me to get rid of this. We'll just keep it on your page there. We'll need that answer later. So our new shape now is going to be of this size, right? We're making a new shape now. We are doubling. This is now going to be 6 meters. That is also going to be 6 meters. This is still 7 meters. These two remained the same. This one has changed. It has been doubled. It's now 6 meters. That's what we mean by doubling. In other words, we've used a constant number 2 to make it 2 times bigger, to increase the size of our prism. Therefore, our new volume is going to be length times breadth times height. It's still the length times the breadth times the height. So meaning it's going to be 7 meters multiplied by 6 meters multiplied by another 6 meters for the height. Then when we simplify here, what are we getting? Quickly punch that out. Yes, we are getting 252 cubic meters. It's now 252 cubic meters. Now, if we compare, because the next question says, what effect did the doubling of the width of the tank have on the volume of the original tank? Remember, the volume of the original tank was 126 cubic meters, is to 252 cubic meters, the new one. If we simplify this divide and go, then if we divide both sides by 126, I think it's a factor, 126 there, the ratio becomes 1:2. The ratio is now 1:2. And what we are realizing that the new volume is double the original volume. But what did we do to the dimension? We doubled it. And what is the effect? The volume gets doubled also. The same tool that we used to double our one dimension now speaks to the volume to say our volume now becomes 2 times bigger than the original volume. Our original volume was 126 cubic meters. Our new volume is like we have just doubled that volume. So that's the effect of introducing a constant to one of the dimensions. In this case, we multiplied our 3 meters by 2, it became a 6 meters. When we worked out our new volume, it became 252 cubic meters compared to the original volume, which was 126 cubic meters. As we compare the two volumes, we realize that the ratio circles to 1:2, implying that our new shape is 2 times in volume bigger than the original, and implying further that our original is half of the new shape in terms of volume. So this is one effect that we are seeing here, that when you change one dimension of your prism by a particular constant K, that particular constant will affect volume. It's like you are multiplying your volume by that particular constant that you have introduced. If you use a half, it means we expect the volume to come down by half times, which is now going to be 63. If we use a 3, we'd expect it to be 3 times more. That's what I'm seeing from here. We shall see with other diagrams. Let's proceed, unless if there are some questions. Yes, if there are no questions, we are going to proceed to our next example, which is still under volume and surface area of these prisms. Remember, we are saying this is a prism also. Never mind, we call it a cylinder, but by definition, it also qualifies to be a prism because it's a circular-based prism. These are circles that are piling up to a height of 15 meters, and their diameter are 14 centimeters. Remember, what is the diameter? That black line is our diameter. Let me label it as AB. Our line AB is a diameter. It runs from one point on the circumference through the center of the circle to another point in a straight line form. That line is called a diameter. And from a diameter, we can obviously get the radius, which is half of the diameter. From A to the center, I can call that center O. From A to O is the radius. Then from O to B, another radius. 2 radii form a diameter. In the actual fact, that is our D at the top there. That's our diameter D. Right, so the question says the diagram alongside shows a cylindrical container for storing a chemical at a particular industrial company. The container is sealed on both ends. You need to be very, very careful about such questions, because sometimes they will give you a container that is not closed at the top, especially with drinking glasses, and they will never mention that it's closed. The moment they say it's a drinking glass, under normal circumstances, our glasses are not closed at the top. So you need to be careful when you are finding the total surface area, because it means one ring is missing. Then the diameter of the cylinder is 14 centimeters and the height is 15 centimeters. It was just a small cylindrical shape that is used for storing chemicals. The first part of the question says, calculate the volume of the container for 2 marks. The next part of the question says, determine the area of the container which is in contact with the chemical. Remember, the chemical is contained in that prism. So it means it's touching certain surfaces from inside in the prism. So indirectly, that question is saying to determine the total surface area of your prism, which is your cylinder. You need to be very, very careful on this question. It says determine the area of the container which is in contact with the chemical. That's basically the total surface area, because the chemical is touching the lid at the top and is touching the lid at the base, and is also touching the curving part inside the container. So you're basically finding the total surface area. Then 2.3 says, due to high demand of the chemical, the height of these containers are multiplied by 3. They are made 3 times higher, which makes it 45 now. Calculate the volume of the new container or the new containers. How much would they hold now? How much space would they take? Don't confuse volume with capacity. Obviously, if you increase volume, capacity will also increase, because the container is much bigger now. Then what was the effect on volume of multiplying that height by 3, making it 45 now? What was the effect on volume? Same as the previous question. Okay, I'm going to give you a few minutes, at most 1 minute or 2 minutes to go through the whole question on your own, attempt that question, but there are some formula that you'll need here. Bearing in mind what I said earlier on, if you are stuck with a prism and you can't remember the formula, what do? Yes, you look at the base of your prism. Look at the base of your prism. If it's a circular based prism, think of what formula you can use for that base, what shape it is, what regular shape, 2D shape you know it is. If it's a circle, how to find the area of a circle? Then just multiply that by the height. You'll know your formula. Or simple substitute and get the volume. Let's proceed. I'm going to give you 1 more minute. This question is worth 6 marks, so the most you can spend 6 minutes on such a question. The mark allocation can also guide you as to how much time you can spend on a particular question. So if my question is 2 marks, I would expect to spend the most 2 minutes. And then if it's 3 marks, I must spend around 3 minutes, but don't wait if you can finish it within less than 3 minutes. If it's 1 mark, try to spend a minute or less to save time for other tricky questions. Right, thank you. Let's proceed. This is what we are looking at, and this is what we are talking about. These are important formulae. I hope you manage them. If not, these are the formulae that we need to answer this particular question. The volume of a cylinder is given by pi r squared h. Why pi r squared h? If I hide my h, it means I have pi r squared. That pi r squared, these are circles piling up to a certain height. That automatically becomes your volume. So the base is a circle, area of a circle is pi r squared from lower grades. Then when you multiply by the height of that particular prism, it will take you to volume. Then we are going to break this down so that we have surface area is going to be 2 rings and a rectangle when you cut that shape open. But before we cut it open, let us not forget the following. There is what we call the circumference of a circle. You will need that circumference of a circle to define the area of your curved surface area for the given cylinder. So if you look at this ring here, this is our circumference. Distance right round that is our C for circumference. If you want to know the distance right round a ring, is given by the formula C is equals to 2 pi r or pi d, but we prefer it in terms of r. So every time you are dealing with a circle and you want to know the total distance right round that ring, is given by the formula 2 pi r. Then when we cut this thing open, what was the curve circumference now becomes one of the dimensions. This is your height, this is your circumference. So when you cut this thing open, it will form a rectangle whose dimensions are 2 pi r, which was the curving part, and then h, which is the height of that. Therefore, your area is now going to be length times breadth. That is the area of this shape. Area equals to length times breadth. Our length is whichever looks longer here. I'm going to say 2 pi r is my length, then my breadth is h. So you're basically multiplying those 2 dimensions because the shape has become a rectangle. Dimensions are not the same. It's a rectangle. So area is equals to A equals to length times breadth. Then you replace, you'll get 2 pi RH. That 2 pi RH is already a formula for the curved surface part of our cylinder. But since the containers are sealed on both ends, it means we have a ring at the bottom and a ring at the top. Hence we sit with 2 rings here. As long as it is sealed on both ends, we are going to have 2 rings and a rectangle when we cut that curved surface area open. That gives us 2 pi RH becomes the area. Therefore we add up all those 3, pi r squared plus pi r squared will give us 2 of them, which is 2 pi r squared, plus the curved surface area, which is 2 pi RH. When we add these 2, the answer becomes this 2 pi r squared plus 2 pi RH. And when we go back to our algebra, we can see there is a common factor. Our common factor is 2 pi r. When we factor out 2 pi r in the bracket, we are going to remain with r plus h. These are the most important formulae that you need to know when you are dealing with a cylinder. And in particular, you need to remember this formula. Circumference equals to 2 pi r. You'll need it when you cut the shape open. It will become one of the dimensions of the rectangle formed, which is that 2 pi r. That was our circular part. It's now straight. The height still remains h. Okay, then we go and answer the questions. The first part of the question said, determine the volume of your prism. So volume, we said these are circles, pi r squared h. Then we replace our r and h. We were told the diameter is equals to 14 centimeters. Therefore, our radius is equals to diameter divided by 2, which is 14 centimeters divided by 2, giving us 7 centimeters becomes our radius. We come back here and substitute pi, then 7. I would prefer that we leave out units for now. 7 squared, because they sometimes confuse, multiplied by the height was 15. But remember, you are dealing with volume. It's a 3-dimensional shape, so it's centimeter cubed. You put your centimeter cubed at the end. We were not going to penalize you for that. It indicates that you have multiplied 7 centimeters squared. There is centimeter times centimeter. Then in 15, there is another centimeter, hence centimeter cubed. You're basically multiplying 3 numbers here. 7 by 7 is already 2 numbers implying 2 dimensions. Then times 15 is a 3rd dimension. That makes it volume. Right, I'm going to keep my answer in terms of pi, both pi. Okay, right, I'm seeing a question here. I shall respond to that as soon as I'm done with this question. Very good, that's a very good question. Right, so I'm going to keep my answer in terms of pi, and if you want to convert to a decimal, we shall convert. So when I multiply here, the rest is calculator work. I'm getting 735 pi centimeter cubed. That's our volume, which is approximately, when we convert to a decimal, is 2309.07 centimeter cubed. That's the answer that you should have obtained there. I have it in terms of pi. If the question says leave your answer in terms of pi, you could have left it there. If they say use the instructions, there is always an instruction on your instructions page which says if the degree of accuracy is not specified in the question, you always round off to 2 decimal places. But otherwise, either answer is correct. But for comparison purposes, you'd rather work with an original answer, which is 735 pi centimeter squares. When you convert to a decimal, it's the answer that you see there. That is how you could have found your volume. Right. Let me go back and address the issue of where the top part of your cylinder is open. If the top part of your cylinder is open, it means one ring is not there. Therefore, your formula here will be volume equal, total surface area. Total surface area is going to be equals to pi r squared plus 2 pi r h. That is if it's open on one end. Why do we have only 1 pi r squared? In other words, we have only one circle. The other circle has been removed. It's still the same similar type of a representation of your formula. Volume is not affected because whether it's sealed at the top or not sealed, it will still reach the same height of 15. It will still reach the same height of 15. It will still take the same space that it takes even if it's sealed. That is volume. But in terms of surface area, there is a missing face, which is the top part. In other words, it has no lid. Your formula will now become pi r squared plus 2 pi r h. It will never change, whether it's sealed or not sealed. But the moment you seal both ends, there will always be 2 rings involved. But here, if you are saying it's open, then it implies that 1 ring shall be excluded. Therefore, your total surface area will be pi r squared, which is 1 circle, then plus the curving part, which is now a rectangular shape. That's the only difference. Otherwise, volume is not affected. Right, let's proceed. Next, we are going to find our total surface area. Our total surface area is going to be equals to, how do you find the total surface area? We have just said the formula is going to be 2 pi r squared because both rings are there, plus 2 pi r h. That's your total surface area formula. It's 2 rings and the curving part. Then from there, what you do, you substitute, or before you substitute, you can factor out your 2 pi r, then you get your r plus h remaining in the bracket. It makes it easy to do your calculations. That formula 2 pi r h, then you replace your r and h. So it becomes 2 pi, let's keep pi, then our r, that is the radius, we say it is 7 into 7 plus 15. Then you simplify and get whatever answer you get there for your total surface area. I'm getting 308 when you punch on your calculator, 308 pi centimeter squares, which is the same as, correct to 2 decimal places. You can convert that by multiplying 308 pi or 308 times pi. Then you convert to decimals. When you convert to decimals, this goes to 967.61 centimeter squares. I hope you got that answer there, provided you knew the formula that need to be used. Right. Then next, the question then said, due to the high demand, the dimension, that is the height, was changed to 3 times bigger, which makes it 45. The new height here will now be 3 multiplied by 15, which will give us 45 centimeters. That will become your new height. So again, you are going to apply your formula to find the volume. We want to see how the volume is going to be affected if we multiply by 3, our height by 3. I'm going to keep the same formula. Let's keep the same formula and then change our height. Let's keep the same formula and change our height. We want to compare the volumes and see how the volumes are affected if we're to change our height and make it 45. Our D is still the same, only the height dimension was changed. So our formula remains the same. What has changed is the height. So volume is going to be pi multiplied by 7 squared, then multiplied by 45. That is our new height, because it has been made 3 times higher. This is centimeter cubed. Then when we evaluate this, I am getting 1470 pi centimeter cubed. When you substitute there, you get 1470 pi centimeter cubed, which is approximately, as a decimal, you can convert that. It gives us, actually when we multiply that, let's quickly multiply and see what we get. Take your calculator, is 7 squared multiplied by 45 is actually 2,000. Let's correct this part here. Is 2,205 pi centimeter cubed. That becomes your new volume, which is approximately, if you multiply this by your pi and convert to a decimal, is approximately 6,927.21 centimeter cubed. That is our new volume from the previous one, which was slightly lower than this, if you still remember. I hope you kept the answers there. Right, so we want to compare and see how do the two compare. Remember, your first volume, I'm going to take the original. The first volume was 735 pi centimeter cubed. Is to the new volume is 2,205 pi centimeter cubed. I want to compare those two. I don't want to compare decimals because I have rounded off. I'll work rather with the originals. When I divide both sides by 735 pi centimeter cubed, I divide this side also by 735 pi centimeter cubed. These will divide and go. I'm left with 1 is 2. If I take my calculator, you can see pi divides and goes, cubic centimeter divide and go. I'm left with 2,205 divide by 735. I'm getting exactly 3. So the ratio is 1 is to 3. My ratio is 1 is to 3. Wow. What does this mean? Remember, we multiplied our dimension height by 3, made it 3 times bigger. But when we find the new volumes, or the new volume versus the old volume, we find that they are in the ratio 1 is to 3. In other words, the new volume is 3 times bigger than the original volume of our prism. So this is the effect again that we are seeing. It doesn't work only for rectangular prisms. It works for any prism to say if you were to change one dimension by multiplying it by a particular constant, what effect would it have on the original volume? That particular number you are using will make the new volume that number of times bigger. If you are using a 2, it will double. If you are using a 3, it will be 3 times bigger in volume, without you necessarily calculating the volume of the new one. So meaning if I knew this skill and I'm asked to find the volume of the new prism, I was going to take my 735 pi and multiply by 3. It will go straight to 2,205 pi centimeter cubed, which would be your volume for the new container. Okay, so in conclusion, what are we saying? We are looking at the effect on volume of multiplying any dimension of a 3D shape by a particular constant. So if one dimension of a 3D shape is multiplied by a constant k, if one dimension is multiplied by a constant k, then the volume of the new shape is k times the volume of the original. Because you affected only one dimension. We have seen it here that if we affect the breadth by 2, the new volume doubles from the original. If we multiply the height by 3, the volume changes by 3. So whatever constant you use, it will affect equally the same the volume. That's the effect that it would have. Now, if 2 dimensions are involved and they are multiplied, both of them, by the same constant k, it means the new volume is going to be k times the original k again. You are multiplying k twice. K times k will give you k squared. So it means you square your constant if 2 dimensions are involved, and you maintained that constant for both dimensions, then multiplied by the original volume. Otherwise, if 3 dimensions are involved and you are using a constant k, you will multiply by k to the power 3. So in general, what are we saying? If in any prism you decide to change the dimensions by a particular constant and you are maintaining that constant, the number of dimensions affected in relation to the constant, the number of dimensions become the exponent of that particular constant. So if I'm changing only one side, it's going to be k to the power 1, 2 to the power 1. If I'm changing 2 sides, it's going to be 2 to the power 2. If I'm changing all 3 sides, if it's a 3D shape, it's going to be 2 to the power 3 multiplied by the original volume. I don't have to literally change the dimensions and use new numbers. As long as it is a constant, I can multiply by that particular constant, but bearing in mind that how many dimensions did I affect? It will indicate how many times the k multiplies itself. That's the effect on any prism on using a particular constant to some given dimensions. Okay, let's proceed. We are going to move on to pyramids now. Remember, these are pointed shapes. All pyramids are pointed at the top. A pyramid is a polyhedron, that's how we define them, formed by joining the edges of a polygon to a point to form rectangular faces. Sometimes it's not rectangular faces, it's curving faces like in a cone, because there are no particular faces because the base is a circle, but it also qualifies to be a pyramid. The volume, therefore, of any pyramid is given by the formula volume equals to 1/3 area of base multiplied by the perpendicular height. There is a reason why our formula is carrying 1/3 there. This was done practical. Where a shape was formed, we shall demonstrate as we continue to see where 1/3 is coming from. Right, but otherwise, the volume of any pyramid, these are pointed at the top, is the area of the base multiplied by the perpendicular height of that particular prism. Then you divide by 3, it will give you your formula for your pyramid, which is the volume in this case. Now, when I look at the examples of our pyramids today, I have this square-based pyramid. In terms of its net, it is made up of a square as a base and then 4 equal triangles. Why equal triangles? Because this is a square-based pyramid. Otherwise, if it was a rectangular-based pyramid, our triangles were not going to be of the same size. Here, all our triangles are congruent because the base is a square. And as you can see, it's pointed at the top there. That is the apex of our pyramid, or the pinnacle of our pyramid is pointed at that particular point, which I will call A there. Otherwise, this is our base. That's what we mean by the base. So if you are finding the volume of this pyramid, you say 1/3. Why 1/3? It has lost some of its parts. It was originally a square-based prism, this thing. Then they chose to fix a particular point and moved all the other faces towards that particular point. And by so doing, the shape lost its original shape, which was a shape of this nature. It was a shape of this nature, which was square-based at the bottom there. It was square-based, but was narrowed in to form a pyramid. Okay. Then the next one is a rectangular-based pyramid, like I indicated earlier on. Its net will have a rectangle as a base and then 4 triangles that will obviously be of different sizes. They will pair up. Opposite ones will be equal in area and equal in size. Those are congruent. Even these ones, they will go together because those opposite sides of a rectangle are equal, if you remember the properties. So if I were to find the total surface area, I would break it down in this manner and have it the way it appears under net. Okay. Right, so we are going to have a look at some questions here, maybe before I address the issue of questions. The question is, how did they know that the area of any pyramid is 1/3 of the area of where it came from? They did a practical research wherein they would make, let's say for instance, a cylindrical shape here. Then they form a cone that uses the same base. They share the same radius there, same radius. They will also share the same height. They share the same height. What was discovered is that when you pour a liquid into this one, let's say it becomes 200 mils, or let's say 600 mils, 600 milliliters. That's the capacity of my cylinder. It's holding 600 milliliters. There, 600. What they discovered is that if they make a cone which has the same height as this cylinder, and then they pour a liquid, this liquid became 200 milliliters. And they discovered that the relationship here is a ratio of 3:2. I mean 6:2, which is 3:1. Or the volume of the cone is 1/3 the volume of the cylinder itself. It's like it was the original cylinder where they fixed a point there and formed a cone from that particular cylinder. As they were forming a cone, some parts of the cylinder were lost. Seemingly 2/3 was lost and 1/3 remained in the form of a cone. So this was based on a practical approach. You can even go and try it with some 3D shapes. Take a cylinder of a particular height, take a cone which has the same base and same height, pour some liquid into the cone and empty it into the cylindrical shape. You will find that you are going to pour 3 times, implying that there are 3 of these cones in that particular cylinder. There are 3 of these square-based pyramids in that particular cuboid. There are 3 of these rectangular-based pyramids in a particular rectangular prism that was using the same dimensions. So it was literally done practical to see how do the two relate with each other. Therefore, our formula is 1/3 area of base multiplied by the perpendicular height. Meaning, if it's a circle, it's a cylinder, I'll find the volume of the cylinder first, then divide by 3. It will automatically give me the volume of the cone, which uses the same radius and same height. That's where that 1/3 came from. Okay, right, let's have a look at this question. This is a November 2017 question. It says a pyramid with a square base with a side length of 16 centimeters is sketched below. P lies on the square base directly below A. That is a perpendicular height. It's always inside the pyramid. The volume of the pyramid is 640 cubic centimeters. The volume is given, and we are also given the formula for finding the volume of a pyramid. Like I said earlier on, if I'm not given the formula, what do? I look at the base. It's a rectangular base. I find the area of the base, which is length times breadth. Hopefully I know the breadth. If I don't know the breadth, then I'll have to find ways of getting that breadth. I find the volume of the area of the base. Then you multiply by the height, that perpendicular height. What you are obtaining is the volume of a normal prism. But you are finding the volume of a pyramid. You then divide by 3. Hence, the formula says volume of a pyramid is equals to 1/3 area of base multiplied by h. That A stands for area of base. Area of base. Then multiplied by the height. That is your A there. Area of base multiplied by the perpendicular height. It's not just a height, because there are quite a number of heights here. We have what we call an edge height, which is your AV, if I may call that V. AV is an edge height. We also have AT, which is a slant height or a lateral height or a median of that particular triangle. So you need to be very, very careful which height you are using. When you talk of the height in these questions, we are referring to the perpendicular height, the one that makes an angle of 90 degrees with the base, which is this height. That's the one that you are referring to. And you can see already a right angle triangle forming there. We can't sometimes divorce Pythagoras' theorem. You also need to think of Pythagoras' theorem in these types of shapes that are pyramids. Sometimes they hide certain information from us. They would expect you to tap on your knowledge from other topics, like for instance, Pythagoras' theorem or trig ratios. SOHCAHTOA, sine is opposite over hypotenuse if an angle has been given to find a missing side. Those are the level 4 types of questions now that will involve angles. But otherwise, a simple question will have its dimensions ready or readily available. Then you simply apply Pythagoras' theorem, it will work. Okay, so here we are told it's a square-based pyramid. Don't forget, this is also 16. So meaning your PT is actually 8 units. Don't forget that. Okay, so the first part of the question says, show that the perpendicular height of the pyramid AP is 7,5 centimeters. How would you show that the height of the pyramid is 7,5 centimeters? Let's proceed. Try to work out the question. The volume was given is 640. Which formula are you going to use? There is the formula given, 1/3 area of base multiplied by height. Then you solve for your height h. That will be your AP. So take down the formula. V equals to 1/3 area of base multiplied by the height. Then you proceed. I'm going to give you 1 minute to find your AP. Yes, thank you. Especially for those that are stuck, you should have started by writing down your formula. Volume equals 1/3 times area of base, 1/3 area of base multiplied by height. Then you substitute 1/3. You look at your base, we said it's a square measuring 16 by 16. So it's 1/3 16 times 16. Then multiplied by the height, and your height is h is unknown. But let's not forget our volume was given as 640. Our volume was given as 640. So we're going to substitute for what we know and then solve for h. That will automatically give us our height, perpendicular height. Then we're going to cross multiply to get rid of 3. Multiply both sides by 3 times 3 this side times 3 on the other side. So these will divide and go. We are now left with 16 times 16. Can multiply that quickly. 16 times 16. That gives us 256. So we're going to have 256 of h. I'm starting with the right hand side so that I keep my h on the left hand side. And I'm solving for h. 256, that is 16 times 16. When you multiply 3 multiplied by 640, we're obtaining 1920. 1920 is the other side. Then we divide both sides by 256. I deliberately left units out because they sometimes confuse. Then divide both sides by 256. Whether it goes an exact number of times or not, I'm not worried about that, because all I want is to make h the subject of the formula. Then I take my calculator, I divide those two. 1920 divide by 256 and see what answer I get. 1920 divide by 256, it gives me 15/2. Then I press SD on the calculator to convert it to a decimal. It gives me exactly 7,5. So it means my height is 7,5. Then I bring my units centimeters. Therefore, according to the question, that height is AP is equals to 7,5. So they will give you a mark for substituting into the correct formula, then a mark for simplification. They can't give you a mark for 7.5 because it was given. So that's how you could have found your, or rather proven that AP is 7,5 centimeters. You write down your formula. Volume of any pyramid is 1/3 area of base. You focus on the base, get the area of the base, divide by 3, then multiply by height. That is automatically your volume. Then here we substituted for volume, we substituted for the area of the base, then solve for h, which is our height. Then simplify and get your 7.5. Then the next part of the question said determine the total surface area. Remember, the total surface area depends on the shape that has been formed. The shape that was formed is a square-based pyramid. So there are 5 faces that are involved. But fortunately, as the 4 triangles that are involved in our net are all of the same size, we just need to find the perpendicular height of our triangle. Based on the sketch that is given here, we need to find our AT, which is the height, this height here, the one that is in broken lines. We need to find that height. So for us to find that height, let's call it the lateral height, the side height. I will call it AT. In the actual fact, it's AT. So we know AP is 7.5. We know PT is 8. We need to find our AT. How would you find your AT? Look at that shape, APT. APT is a right-angled triangle. That will lead us to our triangle AVP. Yes, there is a question which says, are we able to use different ways to get to the answer? Yes, I guess your different ways that you are talking about there is the manipulation of your question. Yes, some learners can keep it as 16 times 16 throughout. Some can keep it as 3 times 640 throughout. But otherwise, you need to work with the correct formula. Eventually, always will lead to 7.5. Yes, in my case, I was simplifying piece by piece. But in your case, if you want to maintain 16 times 16 throughout and then 3 times 40 throughout, that is another different way of doing it. What may not be different is the formula. The formula stays the same, especially in this case. Okay. All right. So we proceed. We are saying we are going to extract our, this is our T, this is our A, this is our 90, this is our AP. We already know AP is 7.5. And then we know this is 8. Remember, it's going to the center of the circle from T, which is half of 16. Then we apply Pythagoras theorem to find the length of AT. So our AT squared is equals to 7.5 squared added to 8 squared, which gives us our hypotenuse. We'll call this our L or AT, still fine. Therefore, simplifying this will give us AT squared. Punch that out for me and give me the answer. 7.5 squared plus 8 squared. What are you getting? Yes, I'm getting 481 divided by 4. It's a fractional answer because of that 7.5. Then you take your square root of both sides. Our AT equals to plus or minus square root of 481 divided by 4, which is plus or minus square root of 481 is an irrational number. You can't evaluate that, but you can get the square root of 4 is a 2. So I would rather keep my answer as, therefore, our AT is equals to square root of 481 divided by 2. That is going to be our AT. Then what does this mean? It means we are now going to go to our triangles that form that prism, actually pyramid. This is going to be our AT. This is our AT. We already know its length is root 481 over 2. And we know this length down here, we said is a 16. Remember the dimensions of the base was a square. I'm looking at the side now. That is a 16. So basically this is half base times height. And your height is square root of 481 divided by 2. That becomes your height now. We are interested in that height because we are focusing now on this part of our shape, which is this front triangle here. We want to know the height of each triangle used there. And they've suggested that we use AT as our height for each one of those triangles. So we've applied Pythagoras theorem to get AT, which happens to be the median of that triangle that has been formed, which is what you see here. This is our AT there, whose height is root 481 over 2. Now that we know our height of that triangle, it means the 4 triangles in that net will have the same height of square root of 481 divided by 2. Then how do we proceed to find the total surface area now? Our total surface area, let's quickly have space here. Right, let's have a look at our total surface area. Our total surface area, remember there is a square base and then there are these 4 triangles, which is 16 there. That is our root 481 over 2. That's the height of each triangle. But there are 4 of them. There are 4 of these based on what you are seeing there as a net. Another one there. Another one there. There will be 4 of them with the same what? With the same area. There will be 4 of them. Right, this is what I'm talking about as a net. So I'm focusing on this. This is your right angle. So our total surface area is going to be 16 by 16. That is the base, which is a square, added to 4 times the area of each triangle, which is half base times height. Therefore, it's going to be 256 added to 4 times half. The base is 16 and the height is square root of 481 divided by 2. Then the rest is calculator work. So what was important here was to get the height of each triangle. Then you simplify. I'm getting 606.91 square centimeters. Why did we multiply the area of triangles by 4? Because the base was in the form of a square, and these triangles are all reaching the same altitude, which is the pinnacle or apex of your pyramid. Okay, right, let's move on to the next part of the question. This one is a special pyramid, which is a cone, right? In a cone, we have these 2 faces. There is what we call a lateral face and a circular base. It's made up of a circle at the bottom. The volume of a cone is given by 1/3 area of base times height. You see, if you height 1/3 pi r squared h is a cylinder. So all cones come from cylinders. If you divide by 3, it will give you the volume of the cone that uses the same base in terms of the circle. Then when you destroy your cone, it will give these 2 faces, what we call the curved surface area and the circular base, which is a circle. That is the net of a cone. Then the curved surface area is given by the formula pi rs. Some books say pi rl for lateral height. This is your L for lateral height. Right. Then the total surface area, therefore, is going to be given by pi r squared plus pi rs. I think this is straightforward. Given this formula, most of this formula will be provided in your exams. You don't have to cram them. The curved surface area of a cone is given by pi rs. We don't even need to prove it. It's given to us. Pi rs, whereas the base is a circle, so it's pi r squared. Therefore, if we were to put these faces together, the total surface area is going to be given by pi r squared plus pi rs. Adding those 2 together will give you your total surface area. Right, activity 2. It says the diagram below shows a cone with a perpendicular height of h, a radius of r centimeters, and a slant height of 13. Already I can see Pythagoras' theorem there. Determine the volume. The volume of the cone is 1/3 pi r squared h. This is the November 2018 question. Total surface area of the cone is pi r squared plus pi rs. Like I said earlier on, this formula will always be provided. Right, the next question then says, show that the volume of the cone is given by V equals to 169 pi h minus pi h cubed divided by 3 for 4 marks. Take down the formula. How do you find the volume of a cone? Is 1/3 pi r squared h. But when I look at this question, there is no r in the answer. Volume is in terms of pi and h. So meaning we need to get rid in the formula of r. How would you get rid of that r? Let's proceed. Okay, so we are going to say volume equals to 1/3 pi r squared h. But then let's not forget, if we go back here, we can find by applying Pythagoras' theorem r. Our 13 squared, according to Pythagoras' theorem, is equals to h squared plus r squared. I'm going to take advantage and solve for r squared so that I will go and replace r squared there. This is 169 equals to h squared plus r squared. Let's solve for r. We make r the subject of the formula. So r squared is going to be 169 minus h squared. I'm going to stop here for now. I need that r squared. I'm not going to destroy r squared and solve for r for now, because according to the formula, it says 1/3 area of base times height. Therefore, I'm going to replace now and say 1/3 pi multiplied by r squared. I'm going to take that same r squared I solved for earlier on, which is 169 minus h squared. So I'm going to replace here 169 minus h squared, then multiplied by h. R is eliminated. Then simplify this. This gives me 1/3. I distribute pi. It will be 169 pi, then minus pi h squared multiplied by h on the other side. Next, I distribute h. It's going to be 1/3 into 169 pi h minus pi h cubed, which is the same as saying 169 pi h minus pi h cubed divided by 3. That's how you could have shown that the volume in terms of pi and h is 169 pi h minus pi h squared divided by 3. What we did here, we realized that there is no r in our answer, so we need to get rid of r. How can we get rid of r? We take advantage of the diagram and apply Pythagoras theorem. The longest side squared, which is our hypotenuse squared, equals to the sum of the squares of the other two sides, which is the perpendicular height and the radius. Then we make r squared the subject of the formula. Then we move on to the next part of the question. I think it was just a substitution type of a question. If h is 12 centimeters, determine the total surface area of the cone. Right? We know the total surface area of the cone. Total surface area is given by pi r squared, right? Added to pi r s for slant height. Then we are going to replace there our pi r squared. This is going to be our h is 12, remember? So we're going to say r squared equals 169 minus h squared. We replace h and put a 12. We are told that our h is 12 according to the question. Remember, our r squared is equals to 169 minus h squared. So I'm replacing that. Then I'm getting r squared. That implies r squared equals to 25. Then we solve for r. That will further imply our r is square root of 25. Our r then goes to 5 units. It's a distance. Our r becomes 5 units. Now that we know our r, we go back and replace. Where there is r, we put a 5. So our total surface area will therefore be pi multiplied by 5 squared added to pi multiplied by 5 multiplied by s. Our s is our lateral height, which is a 13. So we multiply that by 13. If you want, you can take it in factorized form because pi r is a common factor. But substituting directly into the formula would then yield the final total surface area. So for your total surface area, you needed to solve for r by replacing h in the previous r squared. Then simplify by taking square root of both sides to get your r is 5 units. Then remember, distance is never negative. So even if the answer is plus or minus 5, you can as well circle for the positive for distance. Therefore, our final answer goes to 282.74 centimeter squares. That becomes your surface area for your cone. Okay. Right, let's proceed to the last part of the question, which speaks to spheres. We are saying a sphere is a 3D shape. A sphere can also be defined as the set of all points that are of the same distance r from a given fixed point in a three-dimensional shape. So these are our spheres. They are ball-like soccer ball, netball ball, volleyball ball. All those are spherical in shape. And all of them are defined by their center. Then the distance from the center to any point in a three-dimensional space will define a sphere. It's round, it's more of circles, but in a 3D shape, three-dimensional space. Right, the volume of any sphere in mathematics is given by the formula 4/3 pi r cubed. And the total surface area is given by 4 pi r squared. There is an r missing there. It's 4 pi r squared. It's like 4 circles put together. That would be your total surface area. If you were to destroy that ball and place it flat, it's like placing 4 circles which use the same radius as your sphere. But otherwise, the volume is given by 4/3 pi r cubed. All these formulae shall always be provided. And our last question for the day will be this question, November 2015, which says a cylindrical aerosol can has a lid in the shape of a hemisphere. A hemisphere is half of a sphere. That is half of a sphere. That's a hemisphere, half of a sphere. That fits exactly on the top of the can. The height of the can is 16 centimeters and the radius of the base is 2.9 as shown there. There is your aerosol. It's like an aerosol is a compressed liquid. Could be gaseous and what have you. The ones that are like sprays. So they are contained in such a prism whose radius is 2.9. And we are asked to determine the volume of the first part then says, calculate the surface area of the can with the lid in place as shown in the figure below. How would you determine the total surface area? The total surface area of the shape given that is made up of a cylinder is also made up of a hemisphere at the top. There is a hemisphere at the top, meaning our bottom part is going to be the cylinder. How do you find the surface area of a cylinder? Total surface area is going to be pi r squared added to, right, if we remove the lid, it means the cylinder is open at the top. There was a question that was asked earlier on. If you remove that lid, it means the cylinder is open at the top. Hence, we don't put 2 pi r this time. We are using only one circle plus our curved surface area for our cylinder added to, we go to the top part, which is a hemisphere. A hemisphere is half of a sphere, so it's going to be plus half of 4 pi r squared. 4 pi r squared is a full is a full sphere's total surface area. But since we are dealing with half of it, it's going to be half of 4 pi r squared. 4 pi r squared is a total surface area of the whole sphere. But today, we are not dealing with a full sphere, we are dealing with half of it. The rest is substitution. Where there is r, we put 2.9 throughout. So we then replace, this is our pi times 2.9 squared added to 2 pi times 2.9 multiplied by the height. Our height is 16 added to half of 4 multiplied by pi, then multiplied by 2.9, the radius squared. Then the rest is calculator work. But what was important here is the formula pi r squared plus 2 pi rh, which is the curved surface area of a cylinder, pi r squared. Why pi r squared instead of 2 rings? That is having a lid which is hemispherical. So if you remove that lid, it means the cylinder is open at the top. Then we add up all these 3 surfaces. The final answer goes to 370.80 centimeter squares. So this was a deliberate question. They didn't ask for volume because volume is just straightforward. We'll substitute using R into the formula. But total surface area here was a bit tricky because you should have noticed that once you remove this lid, the container is open at the top. Therefore, the total surface area here will only be pi r squared plus 2 pi r h plus 1/2 of 4 pi r squared. Half of it divide by 2 because it's a hemisphere. Then you simplify. Then the next part of the question says, which is the last part, if the lid is 80% filled with the liquid, 80% filled with the liquid, there is the lid is 80% filled with the liquid. Determine the volume, calculate the volume of the liquid in the lid. How do you determine the volume of the liquid? Remember, the volume of a sphere is given by 4/3 pi r cubed. But today I'm dealing with half of it and it's 80% full. So the volume of the lid is going to be 80%, which is 80 over 100, multiplied by half. Why half? Is a hemisphere, it's not a full sphere. This formula is for a full sphere, but ours is a hemi. So I'm multiplying by half of it, multiplied by 4/3, multiplied by pi, which is pi first, multiplied by pi. Let's put our pi, multiplied by pi, then times r squared, which is 2.9 squared. 4/3 pi r cubed is the volume of the full sphere, but since we are dealing with a hemi, we are going to divide that by 2. That's why I have introduced half. Why then multiply by 80 over 100? We are told the lid is 80% full. So it's like you are finding the volume of the whole sphere, then you divide by 2 to get the hemisphere, but that hemisphere is not full, it's 80% full. So we then find 80% of that, which is actually 4/5 of it, or 0.8. Yes, there are other ways, of course, of working it out. Like another person asked a question to say, is this the only way? No, it's not the only way. You can start by finding the volume of the full sphere, 4/3 pi r cubed, but bear in mind you are dealing with a hemisphere, divide by 2. Whatever answer you get, you then find 80% of it. That's the total volume of our liquid in the hemisphere, which is 40.86 centimeter cubed. If you punch on your calculator, you're getting 40.86. For such questions, don't have to waste time punching piece by piece. As long as you have chosen the correct formula, correct substitution, so you'll get 1 mark for correct substitution, correct formula, and then final answer. This is how you could have hanged this question on a composite shape. A composite shape being a shape that is a combination of 2 or more. So you need to check and see which shape is which. There is a cylinder and a sphere, but that sphere is not a full sphere, it's a hemisphere. But the formula that are given are for a full sphere. So anything that has to do with that hemisphere, I shall introduce a half to make it hemi. Hemi means half of a sphere. We don't say semisphere, we say northern hemisphere. It's a half of a full sphere. We call them hemispheres. Okay. All right, so this is how you could have answered those questions, boys and girls. Our lesson is going to stop here for today. And in this lesson, we learned the following: identifying different types of prisms, calculating the volume and surface areas of given prisms, cones, cylinders, and spheres. We chose the correct formula, that is, we identified how we choose the correct formula to find volume and surface areas of given shapes. We also studied the effect on volume and surface areas of multiplying any dimension by a constant. Otherwise, here is your worksheet for today. You are given a worksheet. If you go through this, there is the diagram. You will then need to answer the questions based on the diagrams that are given. This will be your number 2. There are the formula given. I can see a cylinder there, the top part being a hemisphere again. And then you answer the questions. All in all, this carries 16 marks. Otherwise, our session is going to end here. And thank you for attending. We'll meet again at some point in time. Until then, start very hard preparing for your upcoming examinations. Thank you for attending and goodbye.